of a neutral rock, all the things that we were really hoping for to find a place that could have been habitable in its past. So as far as I'm concerned, this is fantastic. All the rest is gravy in terms of how the rover is going to go about looking around this area, because it definitely was all the indications of being a habitable environment at one point in time.
I think I'll add to that by adding an additional point that what this does now is that I think with all the planning that Michael was talking about, going into picking the landing site and then effectively exploiting the landing site, we had 400 team members, and before we landed for about 2 months, folks got stuck into mapping this, and that helped us expeditiously find a place that when we landed, no matter where we landed, we would be able to move there and do the instrument checkouts and hopefully a good place. I think what we can do now with the issue of habitability in the bag, with a really good habitability now, we can undertake a more systematic search for a brighter carbon signal, the kind of thing that Paul was talking about. The search for organic carbon is an issue of this mission. And you want to do this as deliberately as possible. You don't want to just wander around and try stuff out. And so we have a search engine now, and there's 3 components to this, as I've stressed in the past. The one is that the primary environment has to have a mechanism by which you enrich whatever carbon signal is there, whatever reason it's there. You'd like to have a good, strong signal. But the problem is that what you see going on in these images is that there's a process that geologists call diagenesis, and it's all this chemical transformation that happens. Sometimes when you make these minerals and chemicals, they actually use the organics as part of this electron flow I was talking about. So they can be degraded. And then you leave the rock sitting around for a couple of billion years, and it's getting bombarded with radiation. This is not a simple problem, and it's going to take us a while, but I think the mission is up to it, and we're really excited to get started on that now. Maybe Dave and Paul want to say something.
Well, I don't know. I think we really ran the table with this analysis, because just coming to this place and analyzing this bedrock, finding an aqueous environment, finding what appeared to be a habitable environment, and with good preservation potential, it kind of covered all the points of what I would call just an elegant sample to analyze with our capability. So I'm really happy we landed at this spot.
Yeah, just add, this is really a different new set of tools with ChemCam on the mast and the survey tools we have, the first definitive mineralogy for a range of minerals with ChemIn, and the capabilities we've described with SAM. And the team is just delighted to be waking up every morning and looking at what's happening on this different planet. It's just tremendously exciting.
Well, next question is from Dan Vergano of USA Today. Dan?
Hi, thanks. Dan Vergano, USA Today. I guess this is for John Grotzinger, or really anyone who can handle it. In the past, you seemed a little pessimistic about getting this kind of signal from this site on the first drilling. What does it mean to have sort of pulled out these chemicals on this attempt about the whole environment of Gale Crater or Mars?
Well, I think that if the pessimism you refer to is that we go into this type of exploration with our guard up, I think it's justified, because when you land on Mars, strange things can happen, and I think if there's a positive message here is that we're getting better at this, and I don't think it's by accident. I think it's the result of the agency having a program of missions that build on top of each other, and that we can now be more predictive about what we're doing, but you still never quite know what's going to happen till we get there. It just so happened that the environment that we've been exploring is one that we have a lot of experience with here on Earth, and I believe that our science team was well prepared for that to really focus and figure out where exactly to drive the rover. But you always need to be careful when you're working on Mars.
Next up, Reuters, Irene.
Thanks, Dwayne. Congratulations. This is pretty exciting stuff you guys are reporting today. I had 2 questions. The first is what else needs to be done for analysis of the the organics to, you mentioned a little bit about the assessments were preliminary. And then the second question probably is for John. I know this is not a life detection mission, but given that you've scored a hole in one so early, how much farther can you push this through the remaining 18 months of the primary mission?
Well, let me start with the organics. We're planning, when we had a pause to look at these software issues, had planned to do 2 more samples. One where we really, instead of one dump about the size that I showed, we put in 3 dumps and really try and increase the signal from very trace compounds. But what we're really looking forward to is getting the second drilled sample where we've really flushed out the drilling system, accomplished 2 things. Number one, there may be a little bit of residue from rock nests still in there. You saw it, in fact, the picture that Dave showed. There's a little bit of that coating on the sample transfer chain. And so we'd like to dilute that out further. And then very long term, we'll have to decide exactly when we decide to use what's our wet chemistry cups. And we have 9 of those, and that'll be a very deliberate decision, and we'll not do that until we're ready. But at some point, we're really looking forward to doing an entirely different type of chemical analysis.
I guess, Irene, the answer to the second half of the question is to underscore what you said, which is that we're not a life detection mission. If there was microbial metabolism going on, we really wouldn't have the ability to measure that. And if there were ancient microfossils in the rock, as good as Molly is, I mean, it can tell us definitively that we have a mudstone here, but it would not be able to resolve individual fossil microbes. What we can do is to survey additional targets that we have picked out, and we still want to go to Mount Sharp, and we hope to get there. And there are different combinations of minerals that we see from orbit that give us different prospects, and what I hope will become a burgeoning new field of comparative planetary habitability. And what that means is that if you look at how we've studied the ancient Earth, and you look at the minerals and compounds and substances that are available, and you look at the ways that different prokaryotic microorganisms can do their metabolism, they use different materials. It's almost like an organism has evolved to exploit every one of these little rock batteries that exists in the record. And so the question is, how many of these different kinds of batteries can we find at Gale Crater? And I think that really becomes our mission, along with the search for organic compounds.
Irene, did you have a follow-up?
Give us a little update on the status of the rover now with the recovery from the computer reboot and the shutdown for the solar activity.
Yeah, I mean, things are looking well. The rover is still on side B, and it's operating just fine. They're still suspending most of the scientific activities for a couple more sols as they sort through what they think was the root cause in the problem of side A, and because they want to make sure that that is a confirmed operational backup for any more operations. And as you mentioned, solar conjunction, we're headed toward that. Basically, we can't talk to the rover, and the rover talk to us for most of the month of April. And so what's going to happen is we'll do some more science activities now through the end of this month, permitting with the engineers confirming that things are safe for us to do those operations. But we will not do another drilling, the second drill hole, until after solar conjunction. So we're not going to start that activity until May.
Our next caller is from the Wall Street Journal, Robert Lee Hutz. Robert Lee?
Yes, thank you. Can you hear me all?
Yes.
Good. So, gentlemen, in a simple, straightforward, declarative sentence, please tell my readers what you have found here and why it is significant.
I'll take a swipe at that. I think we have found a habitable environment that is so benign and supportive of life that probably if this water was around and you had been on the planet, you would have been able to drink it.
I think that did it for him. Before we go on the phone lines again, let me take another question from Twitter. The Opportunity Rover, 3 months, and it's going on for many, many years. How long do you think Curiosity could last?
The half-life of its power is on the order of 84 years. So I expect the rover to be there to shake the first astronaut's hand if the astronaut goes to Gale Crater.
Next up, New York Times, Kenneth Chang. Ken?
Thanks for taking my question. I was wondering, given that these rocks had good preservation, was there a hope or expectation that they actually would have a stronger organic signal? And what does it mean that you don't have a stronger signal?
Go ahead, Paul.
Yeah, I mean, I think we try, since Mars is such a different planet, to go in as much as we can, at least I certainly do, with an open mind. It's one reason we have kind of the broad chemical survey capability we have on SAM. We're looking for signatures wherever they might be. And, you know, I suppose, you know, on Earth it's, you know, finding organics in very, very ancient rocks is a difficult proposition. And so, yeah, no great expectations. We're just looking for the environments that are right in the first place and looking at it as best we can with the tools that we have and see what we see.
Ken, if I can, I'll just add a little bit to that. Paul's reference to the early Earth is, you know, in our history of exploration there, you have to have a search paradigm. And that paradigm gets built on your understanding of the processes that result in the preservation of organics in the rock record. And one of the big things on Earth is that because of plate tectonics, we have a lot of heat that of course exists today. So a lot of organic compounds are degraded in the presence of that heat. On Mars, we actually think the planet cools with time, and so it may not be that heat's the problem, it might be that radiation is the problem, something that we're not so affected by on Earth. So we have these three factors, as I said before, to reiterate them. I think we're all going to have to learn these. The first is the primary concentration mechanism. The second is that all that cool chemistry that creates the habitable environment, including the presence of water itself, is not necessarily a good thing for the preservation of organics. And then the third thing is the radiation environment. And so our trick is to find a place where all three of those things went right, and that could take the entire length of this mission, but we're going to give it our best.
Okay, I just want to remind folks that, particularly the folks who are viewing this program, the community, the social media community, join the conversation at Mars Curiosity and send in a question, #AskNASA. Our next question will be from Nature, Alex Whitsey. Alex?
Thanks. I have a question for John Grotzinger. What does this mean for getting to Mount Sharp? You talked about primary objective becoming now to explore the area. When might you begin a traverse to Mount Sharp?
Well, like Michael was saying, we do, whether we like it or not, we have solar conjunction coming up here. But we've discussed this as a team, and as soon as we get past conjunction, we're gonna jump right into drilling a second sample, because as you know, it's very important to confirm what you've gotten before. With Rocknest, you know, we analyze a couple of scoops, and our goal here is to do a couple of drill holes. And depending on what we find, because we're discovery driven, that, you know, if it continues to look promising, we'll do some more work. If not, we'll get on the road, and we'll probably clean up business with a few things that we pass by to help characterize the overall broad environment. But our decision as a team is to finish up here at John Klein and then hit the road to Mount Sharp.
Okay.